Hey everyone and welcome to another deep dive. Today we're going to be exploring the world of Max Planck. This is a physicist who really shook things up in the world of science. We've got this essay by Jirko Schneeppert. It's called Max Planck, Der Vater der Quantenphysik und seine Entdeckungen. It goes deep into Planck's discoveries and how they basically birthed a whole new field, quantum mechanics. And get this, it's not just some abstract theory, it's like the backbone of technologies we use every day, like lasers, solar panels, even things like quantum computers.
What's really fascinating is that Planck's journey starts with physicists hitting a wall, like a major crisis in their understanding of the universe.
Okay, so paint the picture for us. What was going on back then?
Imagine it's the late 19th century, and physicists are puzzled by something called black body radiation. Basically, a black body is this theoretical object that absorbs all light, no reflection whatsoever. And when you heat it up, it starts glowing, emitting radiation. Now, classical physics had equations to predict how much energy this black body should emit at different frequencies. But here's the catch. Those predictions went totally haywire at high frequencies. Like they were saying a black body should spit out infinite energy, which is obviously impossible.
So it was like the math was saying one thing, but reality was showing something totally different.
Exactly. This was a major head scratcher, and it was dubbed the ultraviolet catastrophe. It basically showed that classical physics, which had been the gold standard for centuries, was starting to crumble when it came to explaining this
And that's
phenomenon.
where Max Planck enters the scene, right?
Precisely. Schneeppert tells us that Planck was this young physicist deeply fascinated by thermodynamics, the science of heat and energy. He was also incredibly meticulous and rigorous in his approach, which allowed him to tackle this ultraviolet catastrophe from a fresh perspective.
So what did Planck do differently? How did he solve this seemingly impossible problem?
Well, in 1900, he proposed something radical. He suggested that energy, unlike what classical physics assumed, isn't continuous. It actually exists in tiny, discrete packets. He called these packets quanta.
Okay, hold on. Discrete packets. So instead of energy flowing like a smooth stream of water, it's more like it comes in individual droplets.
That's a great way to visualize it. It was a complete break from the established way of thinking. It's like saying you can only buy sugar in prepackaged bags, not by the grain. Planck even gave us the equation to calculate the energy of these quanta, EHF, where E is energy, F is frequency, and H is a constant that we now call Planck's constant.
Wow, so he literally rewrote the rules of the game.
Yeah.
But I have to ask, if his idea was so revolutionary, why didn't everyone immediately jump on board?
It's funny, even Planck himself wasn't totally sold on the implications at first. Schneeppert mentions that Planck initially thought of it more as a mathematical trick to make the equations work, rather than a fundamental truth about the universe.
So even geniuses can have a hard time accepting when their own ideas turn everything upside down. But the evidence for this quantum idea started piling up, didn't it?
Absolutely. It started explaining things that classical physics just couldn't. Albert Einstein, for example, used Planck's theory to explain the photoelectric effect, which is basically how shining light on certain materials can knock loose electrons. This was huge, and it earned Einstein a Nobel Prize in 1921, which further solidified the importance of Planck's work.
Okay, so Einstein gets a Nobel Prize for using Planck's theory. But what about Planck himself? Did his work get the recognition it deserved?
Eventually, yes. It's interesting because Schneeppert points out that Planck, despite his revolutionary contributions to physics, was also a deeply traditional person. He valued his academic position and was initially hesitant to fully embrace the radical implications of his own work. Welcome back to our deep dive into the world of Max Planck.
Last time, we left off with Planck's groundbreaking idea that energy comes in these tiny, discrete packets called quanta,
Yeah.
and how it totally revolutionized physics and earned him a Nobel Prize in 1918. But here's what I find even more mind-blowing. This wasn't just some abstract theory. It laid the groundwork for a ton of incredible technologies.
Yeah.
Technologies that we use every single day.
Yeah, Planck's legacy goes far beyond textbooks and equations. His work is woven into the fabric of our modern world, often in ways we don't even realize.
Okay, so let's get specific. What are some examples of how Planck's constant, that little h in his famous equation, shows up in the real world?
Well, let's start with something you probably use all the time, your smartphone. Have you ever noticed how incredibly vibrant the colors are on those screens? That's thanks in part to something called quantum dots.
Quantum dots, I've heard of those. But honestly, I have no idea how they work.
They're these tiny nanoscale semiconductors. And the really cool thing is that the color they emit depends on their size. Schneeppert explains that this is because the size of the dot determines the energy levels. of the electrons inside. And remember, those energy levels are quantized, meaning they can only exist in specific, discrete values, determined by, you guessed it, Planck's constant.
Wait, so you're saying that by simply changing the size of a dot, we can tune the color of light it emits? That's
Absolutely.
incredible.
It's like having a set of miniature light bulbs. But instead of changing the filament, we're manipulating the energy levels of the electrons to create a whole spectrum of colors.
And that's how we get those super sharp, vibrant displays on our phones and TVs.
Ugh.
I never would have guessed that it all goes back to Planck's work on black body radiation.
Yeah, it's amazing how a seemingly abstract theory can have such tangible
Right.
and widespread applications, isn't it? And it doesn't stop there. Think about lasers.
Okay, lasers, they're everywhere,
Yeah.
from barcode scanners at the grocery store to laser eye surgery. But how does Planck's constant fit into all of that?
Well, remember that lasers emit this highly focused beam of light. And that light is made up of photons, those tiny packets of energy. Well, the energy of each photon is determined by Planck's equation, E8F. In a laser, atoms are excited to higher energy levels, and when they drop back down to their normal energy level, they release photons with a very specific energy dictated by Planck's constant.
So it's like each atom in a laser is a tiny little cannon, firing out identical photons.
That's a great analogy, and because all these photons have the same energy
Yeah.
and direction, they create this incredibly focused, coherent beam of light that we call a laser.
So in a way, Planck gave us the key to manipulate light itself at a fundamental level.
Precisely.
Yeah.
And that manipulation has led to countless applications. Lasers are used in telecommunications, manufacturing, medicine, you name it. They're even used in scientific research to probe the mysteries of the universe.
This is blowing my mind. It's like Planck opened up this whole new world of possibilities with his discovery.
And we're still just scratching the surface of what's possible. Take solar panels, for example. They're becoming more and more common as we transition to renewable energy sources. And guess what? They rely on the photoelectric effect, which, as we discussed earlier, was explained by Einstein using Planck's theory.
Right. The photoelectric effect is all about light knocking electrons loose from a material, which generates electricity.
And the energy of those incoming photons, the ones doing the knocking, is determined by, you guessed it, Planck's constant.
So next time I see a solar panel, I'm going to think of Max Planck and how his work is literally helping power our homes and cities. But what about some of the more advanced applications of quantum mechanics, things like quantum computers?
Well, quantum computers are still in their early stages of development, but they have the potential to revolutionize many fields.
What makes quantum computers so different from the computers we use today?
Well, they harness the mind-bending principles of quantum mechanics, like superposition and entanglement, to perform calculations in ways that classical computers simply can't. Schneppet highlights that while a classical computer bit can be either a 0 or a 1, a quantum bit, or qubit, can be both 0 and 1 at the same time, thanks to the principle of superposition.
Hold on, both 0 and 1 at the same time. How is that even possible?
One of the bizarre but fascinating aspects of quantum mechanics. It's like a coin spinning in the air. It's not heads or tails until you stop it and look. Similarly, a qubit can be in a superposition of states until it's measured.
So it's like quantum computers are tapping into this whole new level of computational power. By exploiting this quantum weirdness.
Exactly. And when you combine superposition with entanglement, where two or more qubits are linked together in such a way that their fates are intertwined, you get a system capable of tackling problems that are simply intractable for classical computers.
Wow, it sounds like quantum computers have the potential to change the world as we know it.
Right.
But I have to ask, are there any potential downsides to all this quantum power?
That's a great question, and it's something we'll explore in the final part of our deep dive. We'll delve into the philosophical implications of quantum mechanics, the mind-bending concepts of probability clouds, and the role of the observer, and even touch upon the ethical considerations that arise as quantum technology becomes more powerful.
Okay, I'm definitely intrigued. Can't wait to see where this quantum journey takes us next.
Welcome back to the final part of our deep dive into the world of Max Planck and the quantum revolution.
We've gone from the ultraviolet catastrophe to lasers and quantum computers, but now we're heading into like some truly mind-bending territory. The philosophical implications of quantum mechanics.
Right, get ready to get philosophical.
All right, I'm ready. Let's start with this. How did Planck's work change the way we think about reality itself.
Well, before quantum mechanics came along, physicists pretty much saw the universe as this giant clockwork machine. They thought if you knew the starting conditions, you could, like, in theory, predict the future perfectly. But quantum mechanics, it really threw a wrench into that neat and tidy view.
Because suddenly we're dealing with probability clouds and uncertainty instead of precise locations and trajectories, right?
Exactly. Heisenberg's uncertainty principle, which came directly from the foundation laid by Planck. It tells us that we can't know both the position and momentum of a particle with perfect accuracy. There's this inherent fuzziness to reality at the quantum level.
So it's not just that our measurements are limited, it's that the information itself doesn't exist in a definite way until we measure it. That's pretty wild.
It is, and it's a concept that a lot of physicists, even Planck himself, struggled with. Jorgo Schneppat points out that while Planck accepted the math of quantum mechanics, he wasn't totally comfortable with some of the more radical interpretations. He still leaned towards a more deterministic view of the universe.
So even the father of quantum mechanics had a hard time wrapping his head around some of the philosophical implications of his own work. But this whole debate about the nature of reality and the role of the observer, it's still going on today, right?
No, absolutely. There are a bunch of different interpretations of quantum mechanics, each with its own set of philosophical baggage. Some physicists embrace the idea of multiple universes branching off with every observation, while others try to reconcile quantum mechanics with a more, classical, deterministic view.
Multiple universes splitting off with every decision we make. That sounds like something straight out of science fiction.
It really does, but it just goes to show how profound and far-reaching Planck's initial insight was. Who would have thought that the idea of energy coming in these discrete packets would lead us down such a strange and mind-boggling path?
Okay, love talking about another mind-bending concept, entanglement. This is where two particles are linked in such a way that their fates are intertwined, even if they're separated by huge distances. How does that even work?
Entanglement is one of the most bizarre and counterintuitive predictions of quantum mechanics, but it's been experimentally verified many times over. It's not about information traveling faster than light. It's more about a correlation between the particles, a shared destiny that's established when they're entangled.
So if I measure the state of one entangled particle,
Hmm.
I instantly know the state of the other, no matter how far apart they are. But that doesn't mean we're breaking the speed of light limit, right?
Yeah. Right. Think of it like this. Imagine you and I each have a coin. We flip them at the same time. And they're linked in a way that guarantees they'll always land on opposite sides. If you flip heads, I instantly know I've flipped tails, even if we're miles apart. It's not that information traveled between us faster than light. It's that the correlation was predetermined.
That's a helpful analogy. So entanglement is more about this pre-existing connection than about sending signals faster than light. But why is entanglement so important?
Well, it turns out to be crucial for a lot of emerging quantum technologies like quantum computing and quantum communication. It's the key to unlocking the full potential of these technologies.
Okay, so we've been talking about all the wonders of quantum mechanics and all these amazing technologies it's enabling. But are there any potential downsides? Any ethical considerations we need to think about as this technology gets more and more powerful?
That's a really important question. Schneppat touches on this in his essay, emphasizing that Planck himself was deeply concerned about the potential for misuse of scientific discoveries. As quantum technology advances, we have to be mindful of the ethical implications.
For example, could quantum computers be used to break the encryption we rely on for secure communication and financial transactions?
That's a real concern. Quantum computers are so powerful that they could potentially crack many of the encryption algorithms we use today. That's why researchers are already working hard to develop new quantum-resistant encryption methods.
So in a way, we're in a race against time to stay ahead of the potential threats that quantum computing might pose.
In some ways, yes, but it's important to remember that quantum technology is a tool. And like any tool, it can be used for good or for bad. It's up to us as a society to guide its development in a responsible and ethical way.
So how do we ensure that this incredible power is used for the betterment of humanity and not for harmful purposes?
Well, for one, we need open and transparent discussions about the potential risks and benefits of quantum technology. We need to involve experts from various fields, not just scientists and engineers, but also ethicists, policymakers, and the public in shaping the future of this technology.
It sounds like we need a global conversation about the ethical implications of quantum mechanics.
Yeah,
It's not something we can leave solely in the hands of scientists and engineers.
exactly. Planck himself was a strong advocate for international scientific collaboration. He believed that knowledge should be shared freely and that science could be this unifying force in the world. I think that spirit of collaboration is more important than ever as we navigate the complexities of the quantum age.
So, as we wrap up this deep dive into the world of Max Planck,
Mhm.
what are some of the key takeaways for our listeners? What should they be thinking about as they go out into the world?
Well, I think the biggest takeaway is that Planck's work wasn't just some abstract scientific discovery. It fundamentally changed our understanding of the universe and continues to shape our world in profound ways. From the technology in our pockets to the philosophical questions we grapple with, Planck's legacy is all around us.
It's amazing to think that a single idea, the idea that energy comes in these discrete packets, could have such a far-reaching impact. It just goes to show the power of human curiosity and the importance of questioning even the most fundamental assumptions about the world.
Absolutely. And as we move deeper into the quantum age,
Mm.
I think it's crucial to remember Planck's own approach to science. He was incredibly meticulous and rigorous, but he was also open to new ideas and willing to challenge the status quo. I think that's a spirit we can all learn from.
So to all our listeners out there, keep questioning, keep exploring, and keep an open mind. Who knows, maybe you'll be the one to make the next big breakthrough in our understanding of the universe. Until next time,